Hey guys, in this video, we're going to talk about fine-tuning large language models. We will talk about what is fine-tuning, how fine-tuning works, some different strategies of fine-tuning, and at the end of this video, we will also see a simple tutorial of fine-tuning a simple large language model. So first things first, what is fine-tuning? As you can see, the definition, fine-tuning is the process of adjusting the parameters of a pre-trained large language model to a specific task or domain. So we need to understand one thing. These large language models sometimes produce responses that are biased, and sometimes they produce answers that are made up responses, and that is what we call hallucination. So, to mitigate this hallucination behavior of large language models, we have different methods, strategies. The one that is booming in the industry these days is retrieval augmented generation. So, in retrieval augmented generation, there is an augmentation of external data using a vector database so that LLM can easily retrieve the data, the similar chunk from a vector database, and it can answer back to the user. The next one is prompt engineering. So prompt engineering is basically the art and science of playing with different prompts, user prompts, so that the LLM can understand and answer back. And the third one is what we are talking today. It's fine tuning. So although pre-trained language models like GPT possess vast language knowledge, they lack specialization in specific areas. These pre-trained models are already trained on vast knowledge, but still they don't understand some. For example, if you are working in a healthcare sector and you want to build a large language model application, LLM powered application in your company, and but the language model, pre-trained model, won't understand some of the words that you guys use in your industry or in your startup that is in healthcare. So to use a large language model, you need to fine tune it with your custom data, right? That is where data preparation and training comes into the play. As you can see in the image, fine tuning, it's a step by step method where you select a model. Basically, you need to select a model, pre trained model, GPT model, and then you might already have your data. That is what we call data preparation, and then we train the pre-trained model on that using our data, custom data, and at the end we evaluate the responses of this fine-tuned model to see if it is producing answers or the responses we are looking for. So this is a simple overview of fine-tuning large language models. So what happens after fine-tuning a pre-trained model? So these are some of the capabilities of an LLM after fine-tuning, right? With your custom data, you fine-tune the pre-trained model, and you can use it for different tasks like question answering, language generation, named entity recognition, sentiment analysis, summarization, uh, paraphrase identification, and others. So these are some of the capabilities once you fine tune a large language model, pre-trained language model with your custom data. So uh, this is the importance of fine tuning. Hey guys, so what are some of the best practices of fine tuning? So one is having high quality data set, right? The in the data preparation stage, we need to have high quality data set that we feed the pre-trained model. So um, the responses of our trained model will all depend on the type of quality data that it is trained on. So it is very important to have a high quality data set in the training process. And the next one is fine tuning subsets of our data set. So instead of fine tuning all the using all the data, we can use a subset of our data set to see the answers that the LLM is producing, basically. Right. And then the third one is starting with a smaller model. So instead of suddenly directly picking the large language model, we can choose a smaller model which can use less computational resources. Right. So these are these are the three important best practices for fine tuning large language models. Hey guys, so let's look at some of the fine tuning methods. Okay, so the first one is full model fine tuning. As the name suggests, we're gonna train the whole pre-trained model with our custom data. And the next one is a feature-based fine tuning. Here, only specific layers of the pre-trained model are retrained, basically leveraging the pre-trained knowledge for general knowledge understanding while adapting to the specific task. So basically, only some layers of or components of the LLM pre-trained LLM are retrained here in feature-based fine-tuning. And the third one is parameter efficient fine-tuning. It is more similar to the feature-based fine-tuning, where only a subset of parameters are retrained here, keeping everything the same. And the fourth one is RLHF fine-tuning, that is reinforcement learning from human feedback, where a human is involved here, right? So instead of directly training on labeled data, RLHF relies on human feedback to guide LLM improvement, because here a human will evaluate the model's output. So whenever it provides desirable outputs, he will reward it, and whenever there are undesirable ones, there are some penalties. So that's how a model can easily understand, yeah, I need to produce proper output. So in RLHF fine tuning, human is basically involved. Hey guys, so here is a simple notebook code example of fine tuning LLMs with our own custom data. So here I'm using SingleStore's notebook feature. So if you are new to SingleStore, SingleStore is basically a relational database company, and they started supporting vector data, storage of vector data long back in 2017 itself. And yeah, you can use SingleStore as your vector database. And you can also build a lot of AIML applications using SingleStore. And yeah, they have this cool feature called notebooks, where you can just do a lot of data exploration, data analytics, and also build AIML applications. And one more thing, a single store has a good integration with these AI frameworks like Llama Index, LangChain, etc. So go to singlestore.com, sign up, and they have the free shade tier, which you can use it free forever to create workspace, create database, and create notebooks. Okay, so I have this new notebook, and once you create a new notebook, you land here. And yeah, so let's come back to our tutorial, that is fine tuning LLMs with our own custom data. Here I'm using Gradient AI as our solution, right? So what is Gradient AI? Gradient AI is a solution that provides a lot of LLM models that we can use for fine tuning. So sign up, go to Gradient AI and sign up. And you need to get your workspace ID and access token. It's very easy. Once you sign up, you will get workspace ID from here, and if you go to access token, you will get it from here. And yeah, first things first, install Gradient AI. Pip install Gradient AI and mention your workspace ID, access token, and let's define a base model. We need to define fine tune the base model. So let's define the base model, that is Llama 2 7B chat. And if you go to this Gradient dashboard, you can see there are models, there are fine tuning. If you go to that particular tab, you can create fine tuning using different base models. You can see the base models here. So I'm using llama 27b chat. So that's what mentioned here. And basically we're gonna create a new model adapter with the name Pawan model, and we're gonna add some samples. We're gonna add some samples like input with instructions, that is who is Pawan Balagati, and the responses as our custom data. And we have four inputs here, like who is this person named Pawan Balagati, again some related info about me, and again, what do you know about Pawan Belagatti? Can you tell me about Pawan Belagatti? And yeah, I have added this. You can also add, edit and add whatever you want to train on. So that's our custom data that we have added. And then um, after setting this up, we will have, like, before fine tuning how it answers, and after fine tuning how the model answers. So if you can see, let me run this. Okay, so it will take some time. So what usually happens is, the first time it might answer something generic or something, some hallucinated answer, right? Pawan Belgati is an Indian professional badminton player. He's a two-time bronze medalist. I'm not. So yeah, so after fine tuning, if you can see, after fine tuning, so this answer is before fine tuning, and after fine tuning, you can see that Pawan is an award winning developer advocate and is an author at various technology publications. He works as a developer advocate and all that. So this is how you can fine tune a base model. And yeah, you can use your own custom data here. And let's go back to our example. Let's see. Yeah, it is still working with the iteration 1, iteration 2, iteration 3, and after iteration 3 you can see uh, the proper response. See, now it generated before fine tuning what it generated. Hey, I apologize, but I am not able to provide information on a specific person named Pawan Belagati as of now, and all that. But after fine tuning, since we have already provided the instruction to our base model, it should provide us at the end a proper response for our question. That is, who is Pawan Belagati? Okay, it will take some time, but it will respond back. Yes, there you go. So generate an answer after fine tuning. Pawan is an award winning developer advocate, AIML enthusiast, and a global influencer in the field of AIML DevOps. He is highly sought after speaker and has delivered numerous talks in various conferences and meetups. So as you can see, it basically took a custom data from here. First, it answered some hallucinated answer, and it didn't answer anything. But here, after iterations, it answered us with our custom data. All right, so I'll provide the link to this notebook in the description, so you can go and test and try it out. So this is about fine tuning base model and all about fine tuning. Thanks.